Good day viewers. In this episode, we are going to look at what's required to align biblical cosmology with standard cosmology. We achieve this by recognizing that redshift z equals 0, often cited as the value for the present epoch, is in fact an arbitrarily defined value. The value of z for the present epoch is a datum, and like any datum, can be defined or redefined at will. Z equals 0 is not a measured value, and it is not derived, it is assigned. Redefining z simply acts to scale the solution from z equals 0 to something else, hence billions of years becomes thousands of years, etc. In order to align the biblical model of cosmology with the standard model of cosmology, we show that the following points require consideration. Number 1. The standard model of cosmology is not always reliable at high values of redshift, as proven by the conflicting output utilizing two different cosmology calculators, which you will see. Number 2. The standard model of cosmology disagrees with itself at high values of z, that is, there is no single, uniformly agreed and accepted version of events for a young universe. Number 3. The value of z in the present epoch is a datum, that is, it is an arbitrary assignment. Number 4. Although assigning a value of z equals 0 to the present epoch is entirely logical, there is no immutable physical reason why it must be z equals 0. Number 5. If the universe is young in a biblical model of cosmology, then a high value of redshift z is required. Number 6. If a non-zero value of redshift is assigned to the present epoch, then other physical parameters will also need to be rescaled. Number 7. Nature is nonlinear. The nonlinear relationship between the cosmic microwave background radiation temperature and cosmological expansion is articulated in the publications appearing on slide 2. Please take the time to review these publications for more information. Number 8. The potential existence of multiverses as described by standard physics should also be considered. From the perspective of an observer residing outside our universe, God for example, a high value of redshift associated with our universe in the present epoch, may be a relative measure with respect to the value of redshift associated with other universes. Therefore, aligning a biblical model of cosmology with the standard model of cosmology, must commence with the assignment of a non-zero value of redshift z in the present epoch. Well, that's enough introduction, let's get into it. To start our journey, we shall decompose the standard model of cosmology into some of its key components. That is, cosmological age, scale factor and cosmic microwave background radiation temperature. In the top half of the screen, you can see 4 equations. These are, a general solution to cosmological age, an exact analytical solution to the present age of the universe, a cosmological scale factor solution and a cosmic microwave background radiation temperature solution. The reason these components are important to us, is because they are all a function of redshift z. If you are unfamiliar with the concept of redshift, please refer to the equation in the top right-hand corner of the screen. In addition, please consult the appropriate resource and return to this video presentation afterwards. It is imperative from this point moving forward, that all viewers comprehend the fundamental meaning of z equals 0. That is, the value of redshift in the present epoch equals 0. The question you need to be asking is, why does z equals 0? Well, the answer to this question is very simple. You can see from the redshift equation that z equals 0 when the change in emitted wavelength equals 0. The logic for the change in emitted wavelength equaling 0, is that over small time increments, the effects of cosmological expansion are negligible, and the emitted wavelength has not had the opportunity to stretch. Hence, the change in emitted wavelength equals 0, and therefore, z equals 0. Nevertheless, the value of z for the present epoch is assigned, it is not a derived value, nor is it an assumed value. Assumed values typically have some degree of foundation in experimental measurement. However, cosmological age is a calculation, it is not a measurement. There is no cosmological clock keeping track of cosmological time. Redshift z is a metric for cosmological expansion, and the standard model of cosmology converts z into a value of cosmological age, but what if the calculation is wrong? Since we do not have access to a cosmological clock to verify calculations of cosmological age, we inherently have an issue. To make this calculation process convenient, the standard model of cosmology utilizes z equals 0 as a boundary condition. Hence, z equals 0 cannot be an assumed value because it has no foundation in experimental measurement of cosmological age. Remember, there is no cosmological clock keeping cosmological time. Please note the fact that I have referred to cosmological age, not cosmological expansion. Moreover, there is no explicit, rigorous or inflexible reason why z equals 0 is indisputably required to be a boundary condition. Cosmological age is not an undisputed metric. In fact, University of Ottawa, adjunct professor, Rajendra Gupta, in July 2023, estimated cosmological age to be 26.7 billion years, that is, almost twice the standard model of cosmology estimate of 13.8 billion years. Thus, z equals 0 can only be an assigned value. An assigned value is often termed a datum. For example, the freezing point of water on the Celsius scale. Thus, utilizing this datum, the standard model of cosmology makes direct measurements of various phenomena, and indirectly infers a cosmological age via calculations. One of those direct measurements is the cosmic microwave background radiation temperature. From this, we indirectly infer a cosmological age of approximately 13.8 billion years via computation. Hence, the next metric we will discuss is cosmic microwave background radiation temperature. The equation for this appears next to scale factor, and is a contrivance biasing z equals 0. We can see that it is a contrivance because it does not contain any association with the Hubble constant. The Hubble constant is a measure of the rate of cosmological expansion, and the rate of cosmological expansion is coupled to cosmic microwave background radiation temperature. Therefore, to express CMBR temperature without directly referencing the Hubble constant, is evidence of an incomplete solution. The standard model of cosmology version of CMBR temperature does not contain any connection to the rate of cosmological expansion. Thus, the standard model of cosmology version of cosmic microwave background radiation temperature is an obvious contrivance. However, if we look at the electrogravity-magnetic construct, we can see that the cosmic microwave background radiation temperature equation contains the Hubble constant, as it should. Moreover, utilizing this connectivity to the rate of cosmological expansion, Storti is able to predict that the true cosmological age is actually the Hubble age. This adds approximately 800 million years to the standard model of cosmology estimate, and explains the additional time required for the formation of large-scale galactic structures, as observed by the James Webb Space Telescope. The James Webb Space Telescope has invoked controversy in recent times, due to the fact that large-scale galactic structures appear to have formed much earlier than expected by the standard model of cosmology. However, adding approximately 800 million years to the age of the universe means that the formation of large-scale galactic structures is no surprise. In a manner of speaking, the electrogravity-magnetic construct rescues the standard model of cosmology in this regard. In order to numerically evaluate the indefinite integral t sub z, within the MathCAD 8 professional computational environment, the limit z sub infinity must be numerically defined. The z sub infinity limit represents effective computational infinity, or in other words, effective infinite redshift. This should not be taken literally. This is just a practical limit of the MathCAD 8 professional computational environment. At any rate, it does not really matter too much because we also compute the associated error. We can see from the information on screen that the difference between the general solution t sub z and the exact analytical solution t sub 0 is less than 1,359 years. This is a negligible difference considering that the age of the universe according to both solutions is approximately 13.797 billion years. Moreover, we can also see that the error between t sub z and t sub 0 is less than 10 to the minus 5%. Hence, we have mathematically proven that the difference between t sub z and t sub 0 is negligible. This negligible difference means that our value of effective computational infinity is acceptable and does not need to be modified. Thus, we can utilize this value going forward, in order to align our biblical model of cosmology with the standard model of cosmology. Okay, now that we have established the validity of Z sub infinity, let's move on. The way we are going to align our biblical model of cosmology with the standard model of cosmology involves two steps. The first step demonstrates the method we utilize, but yields the standard model of cosmology result we expect. What actually makes this first step biblical, so to speak, is cosmological age. According to the YouTube link shown, the presenter asserts that the universe is only 6,000 years old, not the 13.8 billion years that the standard model of cosmology states. This means that we can interpret our results as relating to 6,000 years ago, or if the universe was only 6,000 years old. At this stage, which one it is not important. What is important is the method we are utilizing. However, if we put a conventional hat on, for the sake of argument, we can see from the outputs on screen that our results are entirely sensible, and supportive of the standard model of cosmology. So, step 1 validates the biblical model of cosmology methodology, but the results endorse the standard model of cosmology. Let's now take a look at what happens when we do not assign a value of redshift for the present epoch, but we actually calculate one instead, constrained within a biblical time scale. The second step involves determining the value of redshift for the present epoch, when constrained by a biblical time scale. If we insist that the universe is only 6,000 years old, what does the value of redshift need to be? Well, utilizing the same methodology from the previous slide, the required redshift is approximately 17,634. Remember, as discussed extensively on slide 2, a redshift value of 0 is an assignment, it is not a derived value, nor is it an assumed value. But does it make sense to use anything other than 0 as a boundary condition? Well, yes is the short answer, and we shall circle back to this for discussion a bit later in the presentation. However, for now, let's have a look at the value of redshift predicted by two standard model of cosmology calculators, when the universe was only 6,000 years old. This is the output produced by Ned Wright's cosmology calculator. Ned Wright is a research professor at the University of California, Los Angeles. We can see that the results displayed in the blue box are consistent with the standard model of cosmology and the electrogravity-magnetic construct. However, the results in the purple box display a value of redshift when the universe is 6,000 years old, which is significantly different from our redshift result of 17,634. In fact, if we examine the black box, we can see that our redshift result yields a cosmological age of 2,293 years, according to Ned Wright's cosmology calculator. So, which one is correct? Ned Wright's cosmology calculator, or the standard model of cosmology equation we started with on slide 2? Well, to answer this question, we need to examine the output from another cosmology calculator so that we can execute a more comprehensive analysis. This is the output produced by Nick Neddon's cosmology calculator. Nick is a professor at the University of Chicago. We can see that the results displayed in the blue box are consistent with the standard model of cosmology and the electrogravity-magnetic construct, just like Ned Wright's cosmology calculator. However, this is where the agreement ends. The results in the purple box display a value of redshift when the universe is 16,000 years old, which is significantly different from the result presented by Ned Wright's cosmology calculator at the same redshift, that is, a cosmological age of 6,000 years. Moreover, and quite astonishingly, Nick Neddon's cosmology calculator associates a redshift value of 20,194 with a cosmological age of 6,000 years. Hence, our redshift value of 17,634 sits between the outputs produced by the cosmology calculators. Okay, let's now do a side-by-side comparison of both calculators at a redshift value of 17,634. At a redshift value of 17,634, Nick Neddon's cosmology calculator yields a cosmological age of 7,352 years, as opposed to Ned Wright's cosmology calculator value of 2,293 years. In fact, Nick Neddon's cosmology calculator yields a cosmological age of 6,000 years when the redshift value is 20,194. So, as we can see, significant difference exists between the outputs of these cosmology calculators. The obvious question now becomes, why are the results generated by these cosmology calculators so different when the universe is very young? Well, unfortunately, to answer this question definitively, we would need access to their source code. The logical conclusion is that they make different assumptions about the cosmos, hence, they produce different results as they approach the Big Bang. However, what their conflict tells us is that our redshift value, which yields a cosmological age of 6,000 years, is scientifically acceptable. So then, the big question in this video presentation is, why is it okay to assign the value of redshift for the present epoch as being 17,634, instead of 0, in accordance with the standard model of cosmology? Firstly, let's recall that the value of redshift equaling 0 in the present epoch is an assigned value, it is not derived or assumed. We covered this point extensively in the opening slides. Z equals 0 is a datum, and like all datums, it is an arbitrary assignment. Moreover, the standard model of cosmology has issues, one being the relationship between redshift and cosmic microwave background radiation temperature, which we described on an earlier slide as being a contrivance. Here's why. On screen, we can see the relationship between cosmic microwave background radiation temperature and redshift as presented in Ned Wright's lecture notes, by a red line. The significance of this graph is that the relationship is linear. However, nature is nonlinear, and we can immediately understand that the representation of cosmic microwave background radiation temperature in the Z domain is only linear at low values of Z. At higher values of Z, the relationship appearing on screen collapses because competing cosmology calculators produce significantly conflicting values of redshift as they approach the Big Bang. Thus, as we stated on slide 2, the standard model of cosmology version of cosmic microwave background radiation temperature is an obvious contrivance. What this means is that, with respect to redshift, the standard model of cosmology is not always reliable at high values of Z. As mentioned a few moments ago, nature is nonlinear. The nonlinear relationship between the cosmic microwave background radiation temperature and cosmological expansion is articulated in the publications appearing on slide 2. Please take the time to review these publications for more information. So, if the standard model of cosmology is not always reliable at high values of redshift, as proven by the conflicting output utilizing two different cosmology calculators, what does this mean for a biblical model of cosmology? In fact, a more surgical question to ask is, what is the justification for assigning a high value of Z in the present epoch, rather than the standard model of cosmology value of Z equals 0? Well, there are two main justifications. Number 1. The standard model of cosmology disagrees with itself at high values of Z, that is, there is no single, uniformly agreed and accepted version of events for a young universe. Number 2. The value of Z in the present epoch is a datum, that is, it is an arbitrary assignment. There is no immutable physical reason why the present epoch must be assigned the redshift value of Z equals 0. Moreover, the potential existence of multiverses as described by standard physics may also be a justification. From the perspective of an observer residing outside our universe, God for example, a high value of redshift associated with our universe in the present epoch may be a relative measure with respect to the value of redshift associated with other universes. Of course, this is purely speculative, but nevertheless, it is worth considering if we seek to align the biblical model of cosmology with the standard model of cosmology. In addition, should a non-zero value of redshift be assigned to the present epoch, then other physical parameters will also need to be rescaled. Please refer to the biblical CMBR scaling factor appearing on slide 5, as an example. Okay, let's now summarize what we have learned. In order to align the biblical model of cosmology with the standard model of cosmology, the following points require consideration. Number 1. The standard model of cosmology is not always reliable at high values of redshift, as proven by the conflicting output utilizing two different cosmology calculators. Number 2. The standard model of cosmology disagrees with itself at high values of Z, that is, there is no single, uniformly agreed and accepted version of events for a young universe. Number 3. The value of Z in the present epoch is a datum, that is, it is an arbitrary assignment. Number 4. Although assigning a value of Z equals 0 to the present epoch is entirely logical, there is no immutable physical reason why it must be Z equals 0. Number 5. If the universe is 6,000 years old in a biblical model of cosmology construct, then a high value of redshift Z is required. We have estimated this to be Z equals 17,634. Number 6. If a non-zero value of redshift is assigned to the present epoch, then other physical parameters will also need to be rescaled. Please refer to the biblical CMBR scaling factor appearing on slide 5, as an example. Number 7. Nature is nonlinear. The nonlinear relationship between the cosmic microwave background radiation temperature and cosmological expansion is articulated in the publications appearing on slide 2. Please take the time to review these publications for more information. Number 8. The potential existence of multiverses as described by standard physics should also be considered. From the perspective of an observer residing outside our universe, God for example, a high value of redshift associated with our universe in the present epoch, may be a relative measure with respect to the value of redshift associated with other universes. Therefore, aligning a biblical model of cosmology with the standard model of cosmology, must commence with the assignment of a non-zero value of redshift Z in the present epoch.